Hello everyone and welcome. In this video we're going to be answering 4 questions about tire pressure. First, how does tire pressure change with temperature? Second, how does tire pressure affect tire grip? Third, how does tire pressure affect fuel economy? And fourth, how does tire pressure affect tire wear? Now, modern cars come equipped with tire pressure monitoring systems, but the feature is much more rare on older cars. Fortunately, there's a clever solution, as I heard about this Steelmate tire pressure monitoring system from Chris Fix, and it's something you can easily install on nearly any car. The system works by placing a pressure transducer at each tire, and then this information is wirelessly sent to a receiver unit which plugs into the power outlet and displays each tire's pressure. The system can even inform you if you have an air leak in a tire. So our first question, how does tire pressure change with temperature? And you may have heard a rule of thumb where every 10 degrees of Fahrenheit change of ambient temperature, you'll have 1 psi of change in your tire pressure. So where does this come from? Well, it all comes from the ideal gas law, and it's a very simple equation that we can work out to prove this fact. So we have PV equals nRT. P is the absolute pressure within the tire, V is the volume, so it's constant, N is the amount of gas within the tire, this is in moles, and this is also constant, R is a gas constant, which of course is constant, and T is temperature. So if we eliminate the constants, we have P being proportional to T. So pressure and temperature are directly proportional. So let's take an example. Let's say you have a car and in the summer it's driving around, the cold temperature is going to be about 80 degrees Fahrenheit, and then, months pass and now it's winter and you haven't changed your tire pressure. Well, you're probably going to have some air leak anyways, but we're just going to be looking at the pressure differential just from that temperature change. So now we're saying it's winter and it's 30 degrees outside, Fahrenheit. So in Kelvin, this is 300 Kelvin down to 272. You do have to use Kelvin in this equation as it's the absolute rather than a different scale. So our tire pressure, we're going to say it's at 35 psi. Now we have to add ambient pressure to that, which is 14.7 psi. So we're just going to say about 50 absolute psi inside the tire. So now we have a very simple equation, 300 over 272, this over this, is equivalent to 50 over what? So what's our pressure drop going to be? Well, that gives us 45.3 or about 45 psi. So as you can see, with a 10 degree drop or with a 50 degree drop in Fahrenheit, we have a 5 degree drop in psi. So for every 10 degrees, we have 1 psi. Now, if you want this information in Celsius, it's just going to be 1 psi for every 5.6 degrees Celsius change. So how does tire pressure affect grip? Well, let's say you're on a track day and it's sunny and dry. In this case, it can be beneficial to decrease your tire pressure because you can get a larger contact patch and as a result, more grip. That said, the complete opposite can happen in the wet. So here we're going to be talking about hydroplaning. So we've got our tire here and it's traveling and there's water on the ground which piles up in front of the tire, and that tire has to move that water out of the way in order to maintain grip with the ground. So hydroplaning occurs when the average pressure of the tire on the ground is equal to the average pressure of the water pushing back up on that tire. That makes sense because if they're equal, it means it's basically going to be floating. So now, keeping that in mind, a tire's pressure will directly affect its average pressure it's putting down on the ground. So if you increase the tire pressure, you're going to increase the amount of pressure on the ground because you're going to decrease the contact patch, and so you're going to have more pressure on that area. So there's a direct link between your tire pressure and the likelihood of your car to hydroplaning. So the higher your tire pressure, the lower the likelihood of you are to hydroplane, and the lower that tire pressure, it significantly increases the chances of you hydroplaning. So what does this actually look like? Well, if you're looking at the front of the car and you've got the correct tire pressure, you can see that that water will move outside around it, and you'll also have treads which it can move through. But if you have too low of a tire pressure, you're going to start resting on the outside edge, and you'll have this kind of concave area where the water starts to flow underneath the tire because the pressure's too low, and so it'll build up underneath there and you can begin to hydroplane. Now you can also look at this from a perspective of the contact patch. So if you're looking down on the contact patch, here if you have a properly inflated either one of these options where it can flow around, here it may be more difficult for it to flow around, but that's why you're going to have treads and things like that so that the water can pass underneath. But if it's too deflated, that tire is at a really low tire pressure, you can see that contact patch will start to push to the outside of the tire and you can have that water flow underneath. So it's very important to maintain a decent tire pressure, what your manufacturer recommends for your car in order to prevent your vehicle from hydroplaning. Moving on to number 3, how does tire pressure affect fuel economy? And in order to understand that, we need to understand rolling resistance. So rolling resistance is the energy lost as heat when a tire deforms. So it's compressed and then it stretches back out, and in that deformation it loses some of that energy as heat. And so that's rolling resistance, and that's going to be a force that your car has to overcome in order to drive. So there's actually a very strong relationship between rolling resistance and the pressure in your tire, and it's actually an exponential function. So as you decrease, the amount of rolling resistance you have exponentially increases. So Michelin did a study and they reduced the tire pressure of a tire by 1 bar or 14.5 psi from what the manufacturer had set it at, and they noticed a 30% increase in the rolling resistance, and this equates to about a 3 to 5% greater amount of fuel consumption. And as I mentioned, this only gets worse. So as you keep continuing to decrease pressure, you exponentially gain rolling resistance, and that means you exponentially gain how much fuel consumption you're going to have. And our final question, how does tire pressure affect tire wear? So we've got 3 different scenarios here: a properly inflated tire, an overinflated tire, and an underinflated tire. And so looking at each of these, the properly inflated tire, you're going to have even wear and you're going to have a nice contact patch. An overinflated tire, you're going to have more pressure on the center of the tire, and as a result, you're going to wear down that center strip and have wear on the center of the tire rather than an even distribution of the wear. And then an underinflated tire, you're actually going to have increased pressure on the outsides of the tire, on the edges, and so as a result, you're going to wear out those edges first on that tire. So thank you all for watching. Be sure to check out the video description for a link to the product which I used in this video, and if you have any questions or comments, feel free to leave them below.